Hello everyone. Guys, today we are going to discuss UT6 physics section solution. Okay. So the solution of unit test 6 physics portion we are going to discuss. Okay. So guys, you have the question paper with you. So no need to, I am not going to write the question. It's unnecessary wastage of time. What I am going to do is I am just going to read the question and I'll tell you the methodology that how we are going to approach this question. Wherever required, if the question is too tough, I'll solve it fully, or else I will write the formula, tell you the methodology, tell you the modus operandi, and will tell you the answer as well. Fine? Okay. So question number 1 is, a system X is neither in thermal equilibrium with Y nor with Z. Okay. So there is some system X and X is not in equilibrium with Y and X is not in equilibrium with Z. Fine. So then they are asking you that the systems Y and Z must be in thermal equilibrium. No. It is zeroth law. And the zeroth law was that if A is in equilibrium with B and A is in equilibrium with C as well, then B and C will be in equilibrium, but that's not the case here. So must be in thermal equilibrium. No, cannot be in thermal equilibrium. Cannot say. They can be in thermal equilibrium or they cannot be. We are not sure. So next option is may be in thermal equilibrium. Yes, that's correct. Option C is correct. Fine. Next question. So the next question is, an ideal gas expands in such a manner that its pressure and volume can be related by PV square is equal to constant. Okay. So there is an ideal gas and it is expanding. The ideal gas is expanding in such a manner that the pressure volume relation is given to us. This is the pressure volume equation. Okay. So during the process, they are asking us that what is happening to the gas. Gas is expanding, gas is heated, cooled, neither heated, neither cooled. See guys, what is this? We know it is PV to the power gamma is equal to constant process. Fine. And gamma की value यहाँ पे 2 आ रही है, right, for ideal gas. And in case of ideal gas, pay attention, ideal gas expand कर रही है. If ideal gas is expanding, that means what? It is being cooled. Option B. Fine. Easy question था. Third, ideal monoatomic gas is taken through a process where dq is equal to change in heat is equal to 2 times du. Fine. The molar heat capacity for the process where dq is the heat supplied and du is the change in internal energy. Direct formula application can be done. See, they are saying that dq dE relation is given and dq is the heat supplied to the system. We all know. Yes or no? Right. If heat is supplied to the system, so heat will be positive. Okay. Now they are saying molar heat capacity, monoatomic gas. ठीक है? Monoatomic gas. NC delta T. ठीक है ना? NC work done by the gas will be dW will be, pay attention now. dQ I can directly write as du minus du is equal to dW. So du is equal to dW. Fine. Now we know that dW can be given as NC delta T. Fine. Monoatomic gas 1 C. So your options that are given as directly applying the formula, we get 3R. Monoatomic ना 3R होता है. Monoatomic 3. Fine. So that's the answer. Anyway, Next question, fourth. Heat energy absorbed by a system. Acha, which option is it? It is option B. Heat energy absorbed by a system is going through a cyclic process as shown. So they are asking you to find the heat energy and they have represented the system. PV curve बना के दिया है आपको. ठीक है. Okay. Pressure is in kilopascals. This point is 10. $30. And volume is in liters. This is 10. This is 30. Okay. So they are asking you heat energy absorbed by the system. Fine. So work done, heat energy absorbed, they are asking internal energy होगी नहीं. Work done कितना हो जाएगा? Pay attention. Work done is P into delta V. ये difference निकाली, P delta V होएगा, delta V 20 और ये हो गया आपका, यानी इस पॉइंट पे देखिए अरे भाई. ओके चलिए करते हैं. P डेल्टा V पाई आर स्क्वायर वाला सीधा सा फॉर्मूला यहाँ पे लग जाए. इसका हमें इसका एरिया निकालना पड़ेगा ना. वर्क डन विल बी एरिया ऑफ दिस कर्व. एरिया अंडर द कर्व होता है. इसका एरिया निकाल लीजिए. एरिया कैसे निकलता है सर्कल का? पाई आर स्क्वायर होता है. ठीक है. तो यहाँ पे रेडियस, इधर देखिए ये 10 है, ये 20, 10 हो गई रेडियस. 10 हो गई ना रेडियस. कैसे? सी दिस इज रेडियस विल बी 10. हाउ? प्लीज सी. दिस इज 30, दिस इज 10. So difference between them will be 20. So this entire value will be 10 plus 10, that is 20. Yes or no? So if diameter is 20, that means radius is equal to 10. Speak up guys. Now area of this curve you need to find. It is a circular curve, pi r square, that means pi into 10 square. So 10 square pi is the answer. Which option? Option C. Fine. Option C. Clear? Moving on. Okay guys. So next question is, again a curve is given to us and it is of a 1 mole of a monoatomic gas is carried along the process ABCDA as shown. Okay. So you need to find the net work done. Oh, again very easy. Just a minute. I am drawing the curve for you. Okay. Now pay attention. Question 5th. Okay. So A, D, E, C, B. That's what the curve is. Volume is here, it is in meter cube, and this is pressure, and it is in Newton per meter square. Okay. So now they are saying that a monoatomic gas is carried along the process this. So find the net work done. Net work done kitna hoga? See guys, find the area under the curve of this ABC. So triangle, for triangle ABC, the area under the curve will be half base into height. Okay. So how much is the base? Base is 1 into 2. 2 minus 1, that is 1. And height, how much is the height? Moving from 2 to 4. So that is 1. Okay. Fine. Now pay attention. It is anti-clockwise. Okay, minus. चलो इसको आ जाओ. This is clockwise. ठीक है. इसका निकालते हैं for triangle ADE. Let's find the work done for triangle ADE. Again, it will be half base into height. How much is the base? Base is 1, and height is from 1 to 2. It is 1 by 2, and since it is clockwise, it is plus. So total work done will be work done of ABC plus work done of triangle ADE. So 1 minus 1 plus 1 by 2, it will be your 1 by 2 joules. So which option? Yeah, option C. So option C is correct, guys. Okay. Moving on. Next question. So again a figure is given to us. PV curve. Now pay attention. Question 6 it is. Yeah, right. So it is saying that a gas is undergoing from A to B through 3 different processes. Process 1, 2 and 3 as shown. So the heat supplied to gas is Q1, Q2 and Q3. Okay. So gas can move from A to B via 3 different processes. 1, 2 and 3. These are 3 different processes. Getting my point? Okay. And heat supplied in these processes are, for 1 it is Q1, for 2 it is Q2 and for 3 it is Q3. Fine. Then they are asking you, now pay attention guys. Closed system and they are asking the relation. See, for A to B, process is clockwise. Okay. So here the positive. Here for A to B along 3, it will be negative. Or ye from A, for second process, it will neither be positive. I am talking about the work done. Work done for AB will be positive via path 1, will be negative via path 3 and will be nearly same for path 3. Okay. So, and since it is a cyclic process, pay attention guys, since it is a closed loop, cyclic, cyclic, closed it is. That means what? Internal energy will be 0. Yes or no? We all know Q is equal to W plus U for delta U. Since it is cyclic, so delta U will be 0. Closed path system it is. So Q will be equal to W, and Q with W1, as I told you, is positive, W2 is neutral, and W3 is negative. W1 is greater than W2 is greater than W3. So Q1 will be greater than Q2 will be greater than Q3. So option B is correct. Clear? Next question, it is saying a certain mass of an ideal gas is at pressure P1 and volume V1. Okay. It is compressed isothermally. Isothermal compression means temperature is going to remain constant and volume is going to decrease. Okay. And then allowed to expand adiabatically. Okay, fine. Adiabatic expansion, no heat exchanged, until its pressure returns to P1. The gas is then allowed to expand to its original volume. Fine. So see guys, it is compressed. If it is compressed, what will happen? Pay attention now. There is a gas. It is compressed isothermally. No change in temperature. That means no change in pressure. But compression is there. Volume will decrease. Yes or no? Then what are they doing? And pressure will remain constant. And then it is allowed to expand adiabatically. Okay. Now expansion adiabatically, that means pressure is going to increase. Or let me, sorry, just the opposite. Initially it is here, let's say it is here at any pressure P1, V1 they are saying, then they are compressing, okay? Then they are allowing it to expand and then allowing it to return. Okay. So this type of figure whatsoever is there. Yeah, option A. Same type of figure is represented in option A. Easy question. A. It is saying 1 mole of a monoatomic ideal gas undergoes the pressure AB in the given PV diagram. The molar, again they are asking for molar heat capacity for this process will be, okay. So you need to find work done by finding the area of under the curve, so of rectangle and this, okay. And then you can equate it, the work done, with the molar heat capacity formula. Anyway, let us solve. Okay, so guys, first let's find out the work done. So area under the curve, I am shading it. We can find the area of both of these. So इससे आ जाएगा. From here we can get it. So area of this triangle. So area of triangle is half base into height. Base is from V0 to 5 V0, that is 4 V0 into height. Height is from 3 to 6. So 2 1s are 2 2s are. So 6 P0 V0. Fine. Okay. That's for triangle. Now this is rectangle. Pay attention. So for rectangle, it will be, area will be, this is your breadth, 5 V naught minus length into breadth, it will be. So 5 V naught minus V naught, you will get 4 V naught into this 0 to 3 P naught. So 4 3s are 12, P naught, V naught. On adding them, total work done will be 12 P naught, V naught plus 6 P naught, V naught, that is 18 P naught, V naught. Okay, 18 P naught, V naught. Monoatomic gas 3 is the degree of freedom. Okay. So now you can, this is the work done. You can equate this work done with the formula and find the molar heat capacity. Option C is the correct answer. Next is carbon monoxide is carried around a closed cycle ABCA. Carbon monoxide is CO, guys. Where BC is an isothermal process, gas absorbs this much heat and its temperature increases by 300 Kelvin. Graph is shown to you. Increases from 300 Kelvin to 1000 Kelvin via going from A to B. Okay. Guys, simple calculation based. We have already done so many. D option is correct. D. Moving on to 10th. Next question is, an ideal gas undergoes 4 different processes. So 4 different processes are shown to us. This is process 1, 2, 3, 4. This is your PV curve anyway. 4 different processes are adiabatic, isothermal, isobaric and isochoric. Pay attention, guys. Isochoric means where volume is constant. So process 1 is isochoric. Where pressure is constant, that is isobaric. So process 4 is isobaric. We all know that adiabatic curve comes above, or you can say isothermal curve is steeper than adiabatic curve. Yes or no? So your 2 is isothermal and your 3 is adiabatic. So they are asking you which is adiabatic? 3. So which option is it? Option B. Option B. Fine. 3. Process 3 is adiabatic. Next question. Next is, again a PV diagram for ideal gas is shown. Out of the following diagrams, which represents TP diagram? TP means temperature pressure diagram, and they have given the relation here that pressure is equal to constant upon volume. Okay. So as we can see that in PV curve, this is P, this is V. What is happening when body is moving from point 1 to 2? Its volume is increasing and pressure is decreasing. Okay guys? Volume is increasing and pressure is decreasing. Okay. And we have to, pressure is, that means pressure is inversely proportional to volume. Okay, fine. Pressure is inversely proportional to volume. Guys, this relation, look at this relation. We all know PV equals to nRT. If pressure is inversely proportional to volume, that means this thing is constant. Yeah, if this is constant, then only we can say pressure is equal to constant upon volume. And if it is constant, this is number of moles, this is R. So T is the temperature. That means temperature is constant, and temperature is constant. That means isothermal process. Isothermal process means temperature will remain constant, which is represented in graph 3. And pay attention, marking you have to pay attention to if you are moving from 2 to 1. So option, which option it is then? It is option C. Yeah, C. Third graph, option C. Fine. Next question, it is saying, consider two containers A and B containing ideal gases at the same pressure, volume and temperature. So in two containers, ideal gases are there, their pressure, volume and temperature are same. The gas in container A is compressed to half of its original volume isothermally. So gas is compressed to half of the volume isothermally. For isothermal, guys, we know for isothermal container A, isothermal compression is taking place, and isothermal. And for isothermal, we know pressure is inversely proportional to volume. So gas is compressed to half of the original volume. That means pressure is getting doubled anyway. While the gas in container B is compressed to half of its value adiabatically. Okay. It is done adiabatically. Fine. Achha. Okay. I am writing it like this. Here it is PV equals to constant, and for adiabatic, gamma equals to constant. Okay. So pay attention. It is half 2. So this 2 to the power gamma, and it is V by 2, and it is V by 2 to the power gamma. V by 2 to the power gamma. PP gone. So pay attention, V by 2 into 2 to the power gamma. So 2 to the power gamma means 2 to the power gamma minus 1, and this volume is gone. So answer will be, this will go to the numerator, 2 to the power gamma minus 1 will be the answer. Option A. Option A is correct. Clear? Very easy question. Okay, just a minute guys. Let me fetch a glass of water, then we are going to continue. Okay. Next question. Question 15, that is saying that there are 3 copper blocks of masses m1, m2, m3 kilograms respectively are brought into thermal contact till they reach equilibrium. Before contact, they were at temperature T1, T2, T3. So 3 are there. M1, temperature is T1, second is M2, temperature is T2, third is M3, temperature is T3. Okay, these are copper blocks. Assuming there is no heat loss to the surrounding, the equilibrium temperature T. Now they are brought in contact. Okay, let's read it once again. 3 copper blocks, masses are M1, M2, M3, are brought into thermal contact till they reach equilibrium. Now they have reached the equilibrium. Okay, and before they were tested, before the contact was made, T1 was greater than T2 was greater than T3. Now you are assuming that there is no heat loss to the surrounding. So the equilibrium temperature T, you need to find out the equilibrium temperature T, and they are saying S is the specific heat of the surrounding. Okay, equilibrium temperature T. MC delta theta. So that's the state before the contact was established. After the contact, M1 plus M2 plus M3 into T, if T is the equilibrium temperature. Need to find equilibrium temperature. I will transfer M1 plus M2 M3 here. That's the answer. So it is option B. Next, assertion reason. 16th is assertion reason. It is saying during melting of ice, work done by surrounding on ice plus water system is positive. Yes, obviously. If ice is melting, guys, work is done on it. Yes or no? Gaining something, it will be positive. Fine. Reason, volume of the, how do we know that work is positive? Because if you are going to do work on the system, what is going to happen? It is going to compress. Yes or no? So what is the meaning if it is going to compress? Its volume is going to decrease. Yes or no? So instead of saying that system is compressing, they are saying that volume is decreasing. That means work is done on the system. And if work is done on the system, that's why melting is occurring. So both assertion and reason are correct. And reason is the correct explanation of assertion, option A. Next, direct question, guys, direct formula feeding. Velocity of 3 molecules are given. You need to find RMS speed. You can apply root mean square. It is given as 3V, 4V, 5V. Guys, RMS. First square it. So 9V square, 16V square, 25V square. Then take the mean. So 9V square plus 16V square plus 25V square upon 3. So 25, 50. So it will be 50V square upon 3. And then take the root. So that's what we do now. RMS means root mean square. And we start from the reverse direction. So square mean root. Taking the root of it, this is your VRMS. 50V square upon root 3. So if you will take V outside, because in option they have taken V outside, so 50 by 3. Root 50 by 3 into V is VRMS. Option A. Right. Option A. Same answer is given option A. Fine. Next question. It is saying degree of freedom of a molecule of non-linear triatomic gas NH3. Sorry, I am saying NH3. Triatomic na NH2. Non-linear triatomic, and then they are saying ignore the vibrational hata dijiye, you remove the vibrational. So for 3 axis 3 will be the degree of freedom, then for each and every rotation for that also 3, so 3 plus 3. See, for translatory motion 3 will be the degree of freedom. It can do translatory motion along 3 axes x, y, z. So 3 will be the degree of freedom because of that. Then you are talking about rotation, it can rotate about its own axis as well. So for each, one for one molecule, one for another, one for another. So 3 for this. Vibration they are saying to neglect. 3 plus 3 is 6. So I think option C, 18, option C is correct. Okay. Okay, fine. Next question. It's 20. It is saying an inflated rubber balloon contains 1 mole of an ideal gas. Okay. Has a pressure P, volume V, and temperature T. So 1 mole of ideal gas, pressure V, volume V, temperature T. If the temperature rises to 1.1 T, volume is increased to 1.05. So pressure not pressure, temperature they are saying. Temperature is increasing and volume then the final pressure will be such a easy question. See guys, PV equals to nRT. Pressure. Fine. Okay, this is equation number 1. Now pressure we don't know, so let's call it X. Let's call it P dash. Volume is becoming 1.05 times V. NR is not going to change. Temperature is becoming 1.1 T. Okay, divide 2 divided by 1. So P dash into 1.05 V upon PV. NR gone. So 1.1 T upon T. V gone. T gone. Okay. So P dash upon P will be 1.1 upon 1.05. You can solve it. It will be somewhere. And so P dash will be 1.1 upon 1.05 into P. So remove P dash will be approx from P to 1.1 P. So that is option D. Option D. Clear? Easy question. Okay guys, now rings shaped. Question 21. It is saying a ring-shaped tube contains 2 ideal gases with equal masses and molar masses and relative molar masses. When the gases are separated by one fixed partition P and another movable stopper. Okay. Guys, this question is solved so many times. I am directly telling the answer of this question. It is D. 192 will be the answer. 22. It is saying that the given curve represents the variation of temperature as a function of volume for 1 mole of an ideal gas. Which of the following curve best represents variation of pressure as a function of volume? See guys, temperature, volume. That's the relation given. If this is the volume, this is the temperature. If T is directly proportional to V here, that means P will be inversely proportional to V. So, if this is your PV, yes or no? So, option A is correct. Okay. Look, question 23rd, sorry. Direct formula. They are asking average pressure of an ideal gas is 1 by 3 mn V square. Option A. Fine. Direct formula they asked. Next. It is saying according to equipartition law of energy, each particle in the system of particle have energy equal to, they are saying each particle guys. They are saying each particle. So if you are talking about the total along each axis, so 1 by 2 kT, 1 by 2 kT, 1 by 2 kT, it comes out to be 3 by 2 kT. But only in one direction, 1 by 2 kT. So option B. 1 by 2 kT, direct formula, equipartition law. Okay. Next question. Question 25. They are saying a horizontal tube open at both ends is containing a liquid of certain length. At some temperature, when that temperature is changed, the length of a liquid in the tube is not changed. If alpha is the coefficient of linear expansion and gamma is the direct they are asking. They are asking the relation between coefficient of volume expansion and coefficient of linear expansion. We know alpha is the coefficient of linear expansion, beta is the coefficient of areal expansion or superficial expansion, gamma is the coefficient of cubical or volume expansion. The relation is 1:2:3. So, gamma is equal to 3 alpha. Option B. Question 26. It is saying the average kinetic energy of a gas molecule at absolute temperature T. So the kinetic energy of a gas molecule at absolute temperature T. They are saying, guys, just before this we did it. 1 by 2 kT, overall 3 by 2 kT. So kinetic energy is proportional to T. Option C is correct. Direct formula. Next, in kinetic theory of gases, it is assumed that, now they are talking direct question from kinetic theory of gases. Remember guys, in KTG we took several assumptions. Based on several assumptions only we framed kinetic theory of gases. So they are asking about the assumption only. They are saying in KTG it is assumed that molecular collisions are for inelastic duration. Yes or no? So A, it is an assumption. Okay. Next is 28th. The question is the expansion. So a graph is given to us. VT graph, volume temperature. Right. Here volume is given, here temperature is given. Fine. Now let's read. It is saying the expansion of an ideal gas of mass m at a constant pressure P is given by a straight line B. Okay. The expansion of same ideal gas of mass 2m, pressure is doubled, 2P is given by a straight line. Okay. So if expansion of a gas whose mass is m and pressure is P, it is represented by B. Fine. Then if mass is doubled and pressure is also doubled, then the expansion will be represented by which of the following they are asking. It will be represented by B only. You are doubling the mass and pressure. What will be the effect? It is VT. No effect. Option C is correct. This B only. So 29. An ideal gas is initially at temperature T and volume V. Its volume is increased by delta V due to an increase in temperature delta T. Okay. Pressure remaining constant. Again the graph, very easy. Option C is correct, guys. Option C, 29th. The graph is given. Same procedure. Okay. Next is two identical containers joined by a small pipe. Initially contain the same gas at pressure P0 and absolute temperature T0. One container is now maintained at temperature 2 T0. The common pressure direct 4 by 3 P0. Formula application. Okay. Fine. Okay, guys. Okay, guys. So we are going to continue with the solution of UT6 physics section. So question number 32. Okay. So the question is saying that if temperature of the gas remains constant, guys, if temperature is remaining constant, that means the process is isothermal process. Okay. And we know PV is equal to nRT. This thing is constant. So PV is equal to constant. Now they are saying the pressure is decreased by 20%. Okay. So initially this was the case. Let's say the constant is K. So PV was equal to K. This is first equation. Now they are saying you have to decrease the pressure by 20%. So now the remaining pressure will be 80, or you can say 8 by 10 into P into V. This has to be equivalent to K. Yes or no? So guys, now the see, you are multiplying two things and they are equal to a constant. If you are decreasing one thing, then obviously another thing will increase, right or wrong? If you have to do the product of them and if you have to make it equivalent to a same constant, right? So now in order to make it equivalent to the constant K, you have to increase the volume. As soon as you know that you have to increase the volume, few options get eliminated. That is, option B and D are eliminated. Now how much will be the increase? So you can subtract and find out in terms of percentage. It will come out as 25%. Option C is correct. Clear? Okay, next question. Next question is, the figure is shown, PV curve is shown and two curves representing two temperatures are shown. Okay. So now they are asking that which temperature is greater. Obviously, see, this is the T1, T2, this is pressure. Obviously T2 corresponds to pressure. Yes or no? PV के correspond करता है. So higher is the curve, that means higher temperature. So T2 is greater than T1. Or you can say T1 is less than T2. That means your option C is correct. Next. So question number 34. It is saying two monoatomic gases. Two monoatomic gases are at absolute temperatures 300 Kelvin and 350 Kelvin respectively. So the ratio of their average kinetic energy of their molecules. See guys, 3/2 kT is the formula. So for, let's say, first gas, let's call it A. So 3/2 into K. I am talking about the entire gas. That's why I have written 3/2 kT into 300. Okay, 900/2, that is 450 K. For B again 3/2 kT, and here the value of temperature is 350. 2 ones are 175. That is 350, 350 and 450, 525. Comes out as 525 Kelvin. Now they are asking you the ratio. Okay, we are talking about kinetic energy of A and kinetic energy of B. Take the ratio. They are talking about ratio, na? You need to find out the ratio. Right? You can solve it, and on solving your answer will be, okay, if you want I will solve. 450, so 5 nines are 90, 5 ones are 105. Okay, again by 5 you can do 5 ones are 4, 8, 21. By 3 you can do 3 6 are 6:7 is the answer, guys. Right, option B is correct. 6:7. Next question. So now two flasks are connected. The volume of flask 1 is twice that of flask 2, and the system is filled with an ideal gas. So here the ideal gas is at the temperature of 100 Kelvin and here 200. If the mass of the gas in flask S is M, one में mass in one the mass of the gas is M, then what is the mass? You have to find the mass in the second case. Okay. So see guys, since in flask 2, pay attention, in flask 2 temperature is twice. In flask 2, if 100 is the temperature here, let's call it T na. So here the temperature is 2T. So when temperature is, that means temperature is becoming twice of the flask 1, right? So if temperature is becoming twice, that means inverse relation with mass is there, right or wrong? So mass will become 1/4 of it. So if m is the mass, so m by 4 is the answer. Direct formula application. So it is option C. Option C. Moving on. Again, okay, now 36th question, mathematical question. It is saying again that for a gas whose temperature is constant, that means guys, isothermal, PV is constant, right? PV is equal to K. So V is K by P. So what are they saying? By what percentage you should, what percentage pressure of the given mass of the gas should be increased so that volume is decreased by 10%. See guys, you can simply apply the formula here. P1 V1 is equal to P2 V2. Okay. Let the pressure be P and volume be V initially. Now they are saying find the value of P2 so that volume is decreased by 10%. Okay. This will be the P2, and what is the change in it? Find the change. P minus 10P, 10P by 9 minus P upon original into 100. Okay, on solving you will get your answer as you can take the LCM and solve. So 9 10P minus 9P P, so it will be P upon 9P, so into 1 by 9 into 100, 11 point something will come out, 11.1% nearly. So option D is correct. Fine. Next question. It is saying an ideal gas having a pressure P, volume V and the temperature T is allowed to expand adiabatically until its volume becomes 4 root 2 V while its temperature falls by T by 2. So the degree of freedom of this, guys, direct formula you have to apply of ideal gas. Direct relation, option B is correct. Moving on. Next question. It is saying a gas mixture consists of 3 moles of N2 diatomic, 2 moles of helium monoatomic and 1 mole of S2 again diatomic, neglecting all vibrational modes. So vibrational modes are neglected. Okay. So 3 moles of diatomic is there. 2 moles of helium, okay. Total internal energy is NFRT. So you need to find the degree of freedom, right? So degree of freedom for monoatomic, diatomic and triatomic, not triatomic, 2 diatomic are there and 1 monoatomic is there. So pay attention. For monoatomic we know degree of freedom is, you have to neglect the vibrational, so it is 3. Fine. Getting my point? Yes or no? For 1 mole it is 3. So just applying and adding. See, इसके लिए F की value for monoatomic it is 3, 5 and for this also 5. So 5 and the formula is NFRT, right? So N and RT will be same. F comes out to be 13, right? So 13 RT will be the answer. 13 RT is given in option D. So option D is correct. NFRT is the formula for delta U. Anyway, next question. 40th. It is saying that starting with some initial conditions, if an ideal gas expands from V1 to V2 in 3 different ways, the work done by gas is W1 if the process is purely isothermal. So pay attention. Gas is expanding from V1 to V2, that means V2 is greater than V1. Keep this in mind. And this can be done via 3 ways. Okay. In first way, the work done is W1 and the process is isothermal. W2 is purely isobaric. So here delta T is equal to 0. Here delta P is equal to 0, isobaric process. And W3 is purely adiabatic process. Okay. W3 is adiabatic, that means delta Q is equal to 0. Fine. So now what they are asking? They are asking the relation between W1, W2 and W3. So see guys, work done for isobaric will be maximum, and for adiabatic it will be minimum. So W2 will be greater than W1 will be greater than W3. So it is option B. Next. Now a graph is represented in front of us, a PV diagram. So I am going to draw it. Okay. So for one complete cycle, they are asking you to select the option. See, first of all, you need to understand that this is a closed system, and in closed system what happens? Change in internal energy delta U is 0. Since delta U is 0, that means option B and option C get eliminated, because in option B and C they are saying delta U is not 0. Now we are left with option A and option C. Now pay attention. If you talk about heat or change in heat, pay attention. This is anti-clockwise. Guys, we all know delta Q is equal to W plus delta U. For this, delta U is 0, that means delta Q is equal to W, yes or no? And the process is anti-clockwise closed process. So for anti-clockwise, your work done is negative, right or wrong? And work done is directly corresponding to delta Q, that means delta Q will also be negative. So your option D is correct, option D. Okay, again a PV diagram is given to us. Okay, and they are saying a gas is enclosed in a chamber, passes through the cycle as shown. We need to find the net heat added to the system during the process CA. Okay. If the heat QAB added is 20, no heat is transferred adiabatic. BC के दौरान कुछ भी ट्रांसफर नहीं हो रहा, and the work done is 15. Okay. See guys, for BC pay attention. Work, we all know it is a closed system, so again delta Q will be equal to W plus delta U, and delta U is 0, so delta Q is equal to W, yes or no? Okay. Total work done is given as 15, fine. Delta Q for CA is 20 plus delta Q or heat for AB we need to find. So QAB is equal to 15 minus 20, that is minus 5 joules. So option D is correct. Clear? Okay. Now again a diagram is shown. You can see, look at it in your paper. I won't draw it again and again. A PV curve is there. So a PV curve is shown to us, and three paths traversed by a gas on this PV curve are demonstrated. U1, U2 and U3, and these three curves are corresponding to three temperatures T1, T2 and T3, and from our knowledge, from our earlier readings, we know that T3 will be greater than T2 will be greater than T1. So this we know. We have done a question also like this one. So from there only we can directly say. And U1, U2, U3 are the changes in the internal energy. Okay. Fine. See, in process 1, the gas is moving from T1 to T2. That means temperature is increasing. Fine. In process 2 also, gas is moving from T1 to T2, and in process 3 gas is transversing from T1 to T3. Now you have to tell what the internal energy, what will be the relation between these three internal energies. Okay. See guys, it is quite obvious. Internal energy is directly proportional to temperature. We know this or not? U is directly proportional to T, and if U is directly proportional to T, what does it mean? It means that greater change in temperature, okay, greater the transition or higher is the temperature in transition, greater will be the internal energy. Fine, or say change in internal energy, one and the same thing. Now for process 1 and process 2, the gas is traveling from T1 to T2, so for them internal energy will be same, yes or no, right or wrong. And for process 3, the transition is from T1 to T3 and T3 is the highest, so U3. So your option D is correct. Okay. Next question, it is saying which of the following parameters is the same for molecules of all gases at a given temperature. See guys, at given temperature they are saying mass, no speed. See, we know kinetic energy is directly dependent on temperature. So if temperature is same, kinetic energy will also be same. So 44 option D, temperature, sorry, kinetic energy. Fine. 45th, it is saying the pressure of an ideal gas is 2E by 3V. Okay. So pressure of an ideal gas is represented by 2E by 3V. V is obviously volume. So they are saying what is E referring to? So 2 by 3 PV. Pay attention guys. Work energy theorem. Work done is equal to change in kinetic energy, and kinetic energy is 3 by 2 kT anyway. Okay. So I can say that 2, look here, and work done is equal to PV. So PV is equal to 3 by 2 kT. Fine. Okay. Or fine. So if you are talking in terms of kinetic energy, so 2 by 3 into kinetic energy and transfer the volume. So 2 by 3V into kinetic. So this is representing kinetic energy. I just showed it. So 45A, translational kinetic energy. Next question. It is saying that the RMS speed of oxygen molecule in a gas is V. Oxygen molecule की speed V is V. If the temperature is doubled and oxygen molecule dissociates into oxygen atoms, it is saying of oxygen molecules temperature was T here. Now what they are saying double the temperature, and now oxygen molecule has dissociated into oxygen atoms. Fine. Then the RMS speed will be no problem. See, RMS speed is directly proportional to temperature. If temperature is doubling and it is dissociating 2 times, it will become 2 times directly proportional. Yes or no? So if initially it was V, now it will be 2V. So option C is correct. So again, not again, a PT curve is shown to us, pressure, temperature. Pay attention. Something like this is the pressure, temperature. Okay. Now pay attention, they are asking you to recognize the process. A, it is saying isothermal. No, it is not isothermal because temperature is changing. Isobaric, no, not isobaric, pressure is changing. Isochoric, yes, it can be isochoric. Yes or no? V is equal to nRT by P. See? So option C is correct. Clear? We just did depending on the options given to us by option elimination. So it was 47. Oh sorry, I forgot to do, this was 48. Now let us do 47th. I forgot 47. Sorry. So PV by KT represents which quantity? See guys, we all know for gas it is PV equals to nRT. For a molecule it is PV equals to nKT. So PV upon KT is equal to N. Yes or no? Right. And N is what? Number of molecules of the gas. So option D is correct. Theoretical questions, they are very easy. 49th. It is saying vapor is injected at a uniform rate in a closed vessel which was initially evacuated. So there is a vessel and that vessel was evacuated, nothing was there, and now vapor is injected into that vessel. So now the pressure in the vessel, see guys, if the vessel was evacuated, now you are injecting the vapor, so obviously pressure will increase initially, but as you keep on injecting, so now the pressure will decline. So option D. 50th. It is saying a vessel A has volume V, vessel V has volume 2V, both contain some water which has a constant volume. The pressure in the PA and for PB. Oh. guys, PV is equal to P1 V1 is equal to P2 V2. You can apply. PA will be come out equal to PB. It is option A. Okay guys, so thank you. We completed the discussion of the solution of UT6. I hope you understood. Bye. Thank you.